In this video, we're going to talk about the empirical rule. The empirical rule is part of section 3.2 because it discusses the relationship between the standard deviation and the mean. So recall that when a distribution is unimodal and pretty close to symmetric, we use the mean to describe the center and the standard deviation to describe the spread, and that this mean and standard deviation always go together because the mean is part of the standard deviation formula. Well, there's a famous mathematician in 1733 named Abraham de Moivre that showed that for many of these distributions, about 68% of the data is within one standard deviation of the mean, 95% of the data is within two standard deviations of the mean, and 99.7% of the data is within three standard deviations of the mean. We call this the empirical rule. Now, about 75 years later, another very famous mathematician named Gauss figured out the formula that then models this observation, and that model is called the normal model, and we will talk about that in Chapter 7 a whole bunch. But until then, we're going to kind of stick to this empirical rule, and one of the things to keep in mind with the empirical rule is it doesn't just tell us where we will find data, but it will also tell us where we won't find data. So, for example, because of this observation, we know that if there are data values that are 4, 5, or 6 standard deviations, either above or below the mean, that would be very extraordinary and maybe something we should question. So I've got a diagram here showing the empirical rule. And remember that the mu is the population mean and sigma is the population standard deviation. So when you know the mean, that's going to be in the center of this distribution that is unimodal and symmetric. And if you take that mean and add the standard deviation, so that will bring you here, and then take the mean and subtract the standard deviation, then we know that between these two values, we should see approximately 68% of the data. And we can do the same thing for the next set. We would add the standard deviation twice to get to here and subtract it twice to get to here. And then we know that between those two values, we should see 95% of the data. And if we go for 3 standard deviations, meaning we're adding 3 standard deviations to the mean and subtracting 3 standard deviations from the mean, that we know that almost all of our data is between these two values. 99.7% of the data will be between these two values. Let's look at an example of this. So it says some IQ tests are standardized to a normal model with a mean of 100 and a standard deviation of 16. So first, I drew the model, and then we're going to answer these questions. So again, if I've got a normal model, and I'm sorry I'm kind of dropping this word right here, I'm so used to using it, but again, we'll talk more about that in Chapter 7. But meaning that I have a distribution that's unimodal and roughly symmetric. Then the center of that is going to be the mean. And if I add the standard deviation, so when I took 100 plus 16, that gave me 1 standard deviation above the mean. And when I take 100 minus 16, I get 1 standard deviation below the mean. And then I can see that 68% of the data should be within these two values. If I take 100 and add 16 twice, I'll be up here to 132. And if I take 100 and subtract 16 twice, I'll get down here to 68. And I know that 95% of the data is between these two values. And then finally, if I do this again, but 3 times, so if I take 100 and add 16 3 times, I'll get way up here at 148. And if I subtract 16 3 times, I'll be way down here at 52. And I know that 99.7% of my data is between these two values. So let's use this empirical rule and the information that we have here and answer some questions. So it says, about what percent should have a score between 100 and 116? So I'm just going to do like a quick sketch again we know that between 84 and 116, we have 68% of the data. And we know that 100 is directly in the center of this. So if I want to know the distance between 100 and 116, I can divide the 68% by 2, and I'll know that 34% of the data then should be between 100 and 116. For part B, it says about what percent of people should have a score above 116. So again, I'm going to kind of draw the same thing here. I know that 68% of the data should be between 84 and 116, with 100 in the center. But when we look at this model, it means that 100% of the data should be displayed within this curve somehow. So if 68% is between these two values, then I have 32% left over. And I know that this distribution is symmetric. So if I have 32% left over, if I divide that by 2, I know that 16% of the data then should be above this 116 mark, and 16% of the data should be below the 84 mark. And if you add 16 plus 68 plus 16, you'll get 100% of the data. So the question of what percent of the people should have a score above 116, the answer there is 16%. The answer here was 34. For part C, it says about what percent should have scores below 68. So we can do something similar here, but notice that 68 is part of the 95% part of the empirical rule. So I know that if I go from 68 to 132, that 95% of the data is between these two values, with 100 directly in the middle, leaving me with 5% of the data left over. But again, because this is symmetric, if I cut that in half, I know that 2.5% of the data then is above the 132 mark, and 2.5% of the data is below the 68 mark. So when it says what percent should have scores below 68, that would be 2.5%. And then finally it says, in what interval would you expect the central 95% of scores? So this kind of switched the question. Instead of giving you the scores and asking you for the percent, this is giving you the percent and asking you for the interval. It's given right in our display, and I wrote it in part C too, but we know that 95% of the data values are between 68 and 132. So we simply need to write this as an interval. In interval notation, we don't include the end marks here, so we're going to use parentheses and say this goes from 68 to 132. And that's the interval that the 95% of middle scores, central 95% of scores will occur.